exploration of our solar system involves vast distances and harsh environments, two criteria that make it a dangerous endeavor for humans. But since the early days of space exploration, robotic explorers have been paving the way for a human presence, beginning with the Pioneer, Ranger, Mariner, and Surveyor missions of the 1960s, the Viking missions of the 1970s, the Viking and Magellan mission of the 80s, and the numerous missions to Mars in the 90s and since the turn of the century. Robotic explorers are more capable of conducting scientific research than ever before. We can only imagine where future robotic explorers will take us. The following are a few examples of robotic explorers that NASA is currently working on.
This is Athlete, the all-terrain hex-limbed extraterrestrial explorer. Athlete is a new robot being developed by NASA.
Athlete is a really cool robot, and it's unlike any that I've ever seen before.
Julie Townsend develops robots for NASA.
It looks kind of like a spider. It's got a big ring on top, and out of each of the 6 corners on the ring, there is a leg. And each of those legs is a fully articulated robotic arm. It means it can move in any way that your arm can move.
Each limb has a wheel on the end, which enables Athlete to roll over all kinds of terrain, like the terrain you might find on the moon. And that's where this Athlete is going. This 6-limbed robot will support lunar exploration.
The version of Athlete that will go to the moon is nearly 8 meters tall. That's 2.5 times higher than that basketball hoop up there.
It will transport heavy cargo payloads all over the lunar surface. It's even going to carry the habitat that lunar astronauts will live in. The habitat will weigh nearly 14 metric tons. That means Athlete has to be strong enough to carry a school bus.
Athlete can do plenty of other things besides roll around the terrain. Each limb has a tool adapter to attach useful tools such as grippers and drills.
Mounted on each of Athlete's 6 sides is a pair of stereo cameras that will show the surroundings in full panoramic 3D. And NASA is designing Athletes to work together to be even more productive. Athlete is one of the latest in a long line of robots developed by NASA.
These robots do everything from simple tasks to very complex processes. And they can do it in places where we can't presently send humans, like the planet Mars.
We send robots to the surface of Mars, where there's no air to breathe, there's no food to eat, there's no water to drink. The robot doesn't need any of these things. So a human would be very uncomfortable and have a very difficult time to survive on Mars. But for the robot, it's a much easier environment.
NASA's Mars rover robots have already helped scientists learn much about Mars.
All of the information that we have from the orbit of the planet, all the close-up pictures, and especially all the pictures that we have from the surface of Mars, were all taken by robots.
Not to mention the geological discoveries they have made. Robots are helping unravel many of the mysteries of the red planet. So, from the moon to Mars and beyond, robots are taking the first steps into the future, paving the way so we can follow.
We're trying to go where no one or no robot has gone before. We have a cliff butt, and the idea here is like a team working to allow a climber to belay or climb up. We have a team of robots. We have 3 robots, each active, each able to see, each able to conduct its independent control. All 3 are working together as a team to allow one to go up and down cliffs as steep as 75 degrees. To allow rovers to go into these very difficult regions, ones that are very steep, very rocky, we have to give them an agility that is behaviorally intelligent. That is, they have to be able to recognize they're entering a difficult region. They have to be able to control themselves in a way that will allow them to safely access and traverse the regions. Think of your family dog or cat. They respond accordingly when they see a very difficult obstacle or area they have to climb or walk through. Recent orbital observations of Mars show the possibility of ancient water outflows, maybe even current, near cliff sites. Where there is such water outflow, There's very rich mineralogy, interesting geology. The history of the planet is recorded. However, to access these regions, robots must be able to climb into steep and difficult areas. Current robots can't do that.